this video, we're going to go over something called the angle side theorem, also known as the base angle theorem. Perhaps you heard about it in one of those two ways. The angle side theorem states that if two sides of a triangle are congruent, then the angles opposite to those sides are congruent as well. So if you're dealing with a two-column proof, you can write it this way. If two sides of a triangle are congruent, then the two angles opposite those sides are congruent. So let me give you an example. Let's say we have triangle ABC. And let's say if AB is congruent to BC. So let's say AB is 5 and BC is 5. So if AB is congruent to BC, then we could say that the angles opposite to those sides, so this is the opposite angle, A is opposite to side BC, and angle C is opposite to side AB. So those two angles will be congruent. So angle A is congruent to angle C. So if angle A is 30, then angle C has the same measure. It's 30 as well. And so that's the angle side theorem. Now the converse of the angle side theorem is also true. So if two angles of a triangle are congruent, then the sides opposite those angles are congruent as well. So let's look at an example. Let's say this is A, B, and C. So if angle A is 40 degrees, and if angle B is 40, then that means that these two sides, which are opposite to A and B, so opposite to A is side BC, and opposite to angle B is side AC. The opposite sides are congruent. So in a proof, if you could say that angle A is congruent to angle B, then you can make the statement that segment AC is congruent to segment BC. So if AC is 8, BC is 8. And so that's the basic idea behind the angle side theorem and its converse. Now let's work on a math problem. So consider triangle ABC. And let's say that you're given that AB is congruent to BC. And also angle A is equal to 5x plus 10. And angle C is equal to 7x minus 6. With this information, find the measure of angle B. So feel free to pause the video if you want to. So we know that AB is congruent to BC. And according to the angle side theorem, the angles opposite to that must be congruent. So therefore, we can make the statement that angle A is equal to angle C, which means that 5x plus 10 is equal to 7x minus 6. If we could find the value of x, then we could find the measures of angle A and C, and therefore angle B. So what we're going to do is we're going to subtract both sides by 5x, and let's add 6 to both sides simultaneously. So this will cancel, that will cancel. 10 plus 6 is 16. 7x minus 5x is 2x. So now we need to divide both sides by 2. 16 divided by 2 is 8. So x is equal to 8. So now let's calculate the measure of angle A. Angle A is 5x plus 10. So we need to plug in the x value into that expression. So let's replace x with 8, since it's equal to 8. 5 times 8 is 40, and 40 plus 10 is 50. So therefore, angle A is 50 degrees. Now, if angle A is 50, that means that angle C must be 50, because angle A is equal to angle C. Now, the sum of all three angles inside a triangle always adds up to 180. Any three-figure or three-sided figure have a sum of 180 degrees. So angle A plus angle B plus angle C has to add up to 180. So we know that A is 50. We're looking for the measure of B, and angle C is 50. So 50 plus 50 is 100. So B plus 100 is 180. So angle B is 180 minus 100, which means that it's 80 degrees. And so that's the answer for this problem. That's how you could find the missing angle. Sometimes you may encounter situations where you don't have two sides that are congruent. So let's say if we have a scalene triangle where all three sides are different. But let's focus on two sides. Let's say that AB is 11 and BC is 12. So if AB is not equal to BC, what statement can we make regarding angles A and C? What you need to understand is that because 12 is larger or greater than 11, angle A, the angle that's opposite to 12, is going to be greater than angle C, which is opposite to 11. So since BC is greater than AB, the angle that is opposite to BC, which doesn't have these letters, that's going to be angle A. Angle A is going to be greater than angle C. So make sure you understand that. So let's look at another example. This time, we're going to be given three sides instead of two. So let's say that AC is 15, BC is 12, and AB is 13. What statement can you make regarding angles A, B, and C? Now, AC is greater than AB, and AB is greater than BC. So therefore, because AC is the longest side, angle B is going to be the greatest angle because it's opposite to the longest side. So angle B is going to be greater than angle C. C is opposite to AB. And angle C is greater than angle A. So this is the statement that we can make. So basically, what you need to understand is that the longest side is across the largest angle. The shortest side is going to be across the shortest angle. Make sure you get that point. Make sure you understand that. Now let's look at another problem. So let's say this is A, B, and C. Now let's say that we're given that BC is greater than AB. And we're also told that angle A is equal to 9x minus 16. And angle B, or not B, but rather angle C, is equal to 5x plus 8. So what are the restrictions on the value of x? Feel free to pause this video and find the restrictions on x. So if BC is greater than AB, we could say that the angle opposite to BC, A is opposite to BC, that means angle A is greater than the angle opposite to AB, which is angle C. So we're going to focus on this part right here. Angle A is greater than angle C. So we could say that 9x minus 16 is greater than 5x plus 8. So now let's solve the inequality. Now let's subtract both sides by 5x And let's add 16 to both sides. So we can cancel 16 and the 5x. 9x minus 5x is 4x. And let's not forget about the greater than symbol that we have here. And 8 plus 16 is 24. So therefore 4x is greater than 24. Now let's divide by 4. 24 divided by 4 is 6. So therefore we could say that x is greater than 6. So we have an inequality. Now, is there a limit to the value of x? Can x be 100 or 1,000? If x is 100, what is the measure of angle A? 9 times 100 is 900 minus 16. That's going to be 884 degrees. But we know that's not possible because a triangle can only have a total measure of 180 degrees. So therefore, there must be a limit on the maximum value of x. So we know x is greater than 6, but it has to be less than 100. So what is that cap? What is the limit on the value of x? How can we find it? Well, let's get rid of a few things first. Let's make some space. So I'm just going to write above here that x is greater than 6. Now, it's important to understand that angle A plus angle B plus angle C adds up to 180. Now, we only need to focus on angle A and angle C. So if we subtract both sides by angle B, we can see that angle A plus angle C is 180 minus angle B. Now, we don't know the value of angle B, so it has to be greater than 0. Therefore, we could say that if angle A plus angle C, if it's 180 minus B, which is always going to be true, then angle A plus angle C has to be less than 180. Because once you take 180 and subtract it by angle B, you're going to have a value that's less than 180. So this is the inequality that we need to find the maximum value of x. Now we have the value of angle A. We know it's 9x minus 16. And now let's replace angle C with 5x plus 8. So therefore, this whole thing has to be less than 180. Now let's simplify the expression. So let's combine like terms. 9x plus 5x is 14x. Negative 16 plus 8 adds up to negative 8. So now we need to add 8 to both sides. So we could say that 14x is less than 188. And now let's divide both sides by 14. So 188 divided by 14 is 13.4 if you round it to the nearest tenth. So x is less than 13.4. So now we need to combine this inequality with this one. So we could say that x is greater than 6, but it's less than 13.4. And of course, that's a rounded value. So x is between 6 and 13.4. So this is the restriction on x. Now let's work on some two-column proofs that will use the angle side theorem. So let's say this is point A, B, C, D, and on top E. And we're given that AB is congruent to CD. And also that angle A is congruent to angle D. So with this information, go ahead and prove that BE is congruent to CE. So let's make a two-column proof. So we're going to have statements and reasons. So let's make a mental outline of what we need to do. Our goal is to prove that BE and CE are congruent. And in order to do so, we need to show that triangles ABE is congruent to triangle DCE. So if we can prove that those two triangles are congruent, then the corresponding parts of those triangles must be congruent as well. So let's start with the first statement, that AB is congruent to CD. So this is AB, and it's congruent to CD. Now let's not forget to write the reason. So this statement was given. Now let's move on to step 2. We're also told that angle A is congruent to angle D, and that's given as well. And so let's mark it. So here's angle A, and here's angle D. Now, we only need to prove another part of that triangle, of those two triangles. If we can show that another part is congruent, then the two triangles will be congruent. But we've ran out of information. There's nothing else that we have. So what can we do at this point? We need a third piece of information to prove that triangle ABE is congruent to DCE. So what's the missing piece of information? Well, let's redraw the triangle, but we're only going to focus on the large triangle. That is triangle ADE. So, since angle A is equal to angle D, that means that the opposite sides are congruent. So ED has to be congruent to AE, according to the base angle theorem, or the angle side theorem. So AE is congruent to DE. So what can we write as the reason for that statement? We could say, if the angles of a triangle are congruent, then the sides that are opposite to those angles are congruent. So now we can move on to the next part. So according to the let me start with this one, the SAS postulate, the two triangles are congruent. So we can say that triangle ABE is congruent to triangle DCE. And this is the side angle side postulate based on statements 1, 2, and 3. So now we can make the final statement that BE is congruent to CE based on CPCTC. Corresponding parts of congruent triangles are congruent. And so that's it for this particular problem. So now you know how to incorporate the base angle theorem into column proofs. So here it is. And don't forget about the converse of that statement. Now we're going to work on another example, but this is going to be a relatively short proof. So let's call this A, B, and C. We're going to say that this is angle 1, angle 2, angle 3, and angle 4. So given that segment AB is congruent to BC, prove that angle 1 is congruent to angle 4. So go ahead and work on this problem. It's not that difficult if you understand it. So let's start with statement 1. AB is congruent to BC. So that's given. Now let's mark it on the graph. So this is AB, it's congruent to BC. Now, according to the base angle theorem, if the sides are congruent, then the angles opposite those sides must be congruent. So we could say that angle 2 is congruent to angle 3. Now, what can we write as the reason? So we could say that if the two sides of a triangle are congruent, then the two angles opposite those sides must be congruent as well. So hopefully you could see this. I know my drawing can be terrible sometimes. So that's the reason for statement 2. Now we can make the final statement that angle 1 is congruent to angle 4. So what's the reason behind that statement? Let's say if angle 2 is 70 and if angle 3 is 70. Angle 1 is the supplement of angle 2. So angle 1 has to be 110 and angle 4 has to be 110. So 1 equals 4. So here's the reason. Supplements of congruent angles are congruent. So 1 and 4 are the supplements of 2 and 3, and 2 and 3 are congruent to each other. So therefore, 1 and 4 must be congruent to each other. And so that's it for this proof. So now you know how to incorporate the base angle theorem in 2-column proofs. So that's it for this video. Thanks for watching and have a good day.